We're going to be writing functions from a table. When we do these, we're going to be looking for a common difference, for a pattern with the x's and the y's. So if you notice here, you have a +1 and a +1 and a +1 here. And then on this side, we also have +1. So every time the x value goes up by 1, the y value goes up by 1. So the little clue that we were looking at in class to determine whether it was just a simple one-step multiplication or division, or a two-step where you had a multiplication with an addition or a subtraction, is taking a look at the common difference. So the common difference here is +1. But if you notice, the first term is a -2. So that's going to be a hint that we have two steps that's going to be happening here. So if we have f of x equals that common difference, that's your 1x. You don't have to write the 1 in there, but I'm going to write it there just to show you that that's where that number came from. And now we need to say, okay, I need to go from this x of 1 to -2. So how am I going to do that? And you're going to subtract 3. So let's take a look at x is 2. If we wanted to say x is 2, so we would just substitute it in here. And what's that going to give us for an answer? We're going to have 2 minus 3, and that's going to give us -1. Now go ahead and take a look at, I'll erase that over here so we can see this. If x is 2, like we said here, what should that y value be? And if you notice, it is -1 and it matches. So it's just kind of like our proof. So let's go ahead and take a look at the next one with a 3. So if x was 3, you would have 1 times 3 minus 3, and that's going to give you that y value. So you have y equals 3 minus 3, and then you can see it's that 0. So our function rule is f of x equals 1x minus 3, or x minus 3. Now, let me just take a look and show you something that you might have noticed. If you just went straight down to this, look at the x. The x is 3. What do you have to do to that x to get to the y of 0? You have to subtract 3. X minus 3. Well, if x is 4, 4 minus 3 is 1. Sometimes it's easy to figure it out just by looking at what's happening. Sometimes it's not that easy. When it's not that easy, you're going to do what we did originally and just look for those patterns. Let's take a look at the second problem. And you have x values. You have 1 to 2 plus 1, 2 to 3 plus 1, 3 to 4 plus 1. Now let's take a look at here. 5 to 10 is plus 5. 10 to 15 is plus 5. 15 to 20 is plus 5. And this is where that pattern and that relationship comes into play here. Your common difference is 5. Your first term is 5. It's going to be a one-step. F of x equals 5x. You don't need to do anything different. Sometimes, again, it's easy to just go ahead and look at the relationship straight across. 1 to 5. Could it be plus 4? Could it be x plus 4? Because 1 plus 4 is 5. But if you go ahead and look at the second term, 2 plus 4 isn't going to get you to 10. But if you do times 5, 1 times 5 is 5, 2 times 5 is 10, 3 times 5 is 15, 4 times 5 is 20. F of x equals 5x, or y equals 5x. Second one here, again, these are all plus 1, plus 3, plus 3, plus 3. F of x equals 3x. Start to look at the relationship going across. 1 times 3 is 3. 2 times 3 is 6. 3 times 3 is 9. 4 times 3 is 12. Down here we have plus 4. F of x equals 4x. These 4's are the same, this 4 and this 4. Again, 1 times 4 is 4, 2 times 4 is 8, 3 times 4 is 12, 4 times 4 is 16. These are the problems that got to be a little bit more difficult. On the left-hand side here, your hours are your x's, so it's all plus 1. And on the right-hand side, we have a plus 25. Now here's where we know it has to be a two-step function. This is 25, but that's a 65. That's letting you know it's going to be f of x equals 25x. The 25x is coming from the common difference. Now we have to say to ourselves, how am I going to get from 25x to 65? So x is 1. This is our first one. So let's just go ahead and see if we can figure out a pattern. If we said x is 1 and we wanted the answer to end up at 65, what do we have to add to it? Well, 65 minus 25 will give us 40. Okay, so let's see if it works for the second term. 25 times 2 is 50, and then 50 plus 40 is 90, and that's what you were supposed to get. You can go ahead and check it with the third just to be sure, but your function rule here is f of x equals 25x plus 40. Let's take a look at the third one. Again, all the x's going up by 1. Here we have 10 to 16 is plus 6, plus 6, plus 6. Because these are all plus 6's, it's a common difference, then you can say it's a linear function. We know it's going to be f of x equals 6x. That 6 is coming from here. But we have a 10. So we have to say 6 times 1 from that 1 plus something is going to get us the output of 10. And 6 times 1 is 6, plus 4 will get us to 10. 6x plus 4. But let's double check it with the second one. 6 times 2 is 12, plus 4 is 16. And you can check to see if this rule fits with the other ones. Let's check the last one. Okay, 15 to 27 is plus 12. 27 to 39 is plus 12. So we have f of x equals 12x plus. So go back and look at the 1. If we said x is 1, what are we going to add it to get 15 as our y value? And that's going to be 3. Check it with the second one. 12 times 2 is 24, plus 3 is 27. 12 times 3 is 36, plus 3 is 39. Then go ahead and fill it in for the fourth. 12 times 4 is 48, plus 3 is 51. 12 times 5 is 60, plus 3 is 63. Now, like I mentioned in class, you might say, well, I'm just going to add 12 and not even worry about the function rule right here, f of x equals 12x plus 3. But if I were to ask you what the 220th term is, you want to be able to say, well, if she's looking for the 220th, then I can just substitute 220 into here, multiply it by 12, add 3, and get my really big answer right there.